The second law of surds that I want to look at is this one here. It's the square root of AB equals the square root of A times the square root of B. So this is the law that involves multiplication and surds and how they relate to each other. And it's sometimes easy to forget what we mean by AB. Remember, in algebra we sometimes leave the multiplication sign out. So I'm actually just going to insert in here between the two sides that this thing here is the same as, that's what equals means, the same as A times B, find the square root, is the same as doing the square root on the A, doing the square root on the B, and then multiplying them together. So it's kind of a times in there as well. And as with any algebra rule, it's sometimes helpful, that's my terrible drawing there, as with any algebra rule, it's sometimes really helpful to just test these sorts of things out using numbers rather than having to deal with algebra land all the time. So what I'm going to do is I'm going to pick two numbers for A and B, and I probably want them to be square numbers so that it's easy to find the square root. So let's pretend that A is 4, it's a simple square number, and that B is 9. Okay, that's also a simple square number. So let's take this left-hand side of the equation, just here, and go, okay, what if A was 4 and B was 9? Well, then I'd have the square root of 4 times 9. Alright, well that's going to be the square root of, well, 4 times 9, that's 36, because I have to do what's inside there first. 36, and then I've got to find the square root of 36. Well, the square root of 36, 6 sixes are 36, so the square root of 36 is just 6. And if I take this right-hand side, I've got the square root of, we said A was 4, remember? And the square root of B is 9. Okay. Square root of 4, well that's 2. And the square root of 9 is 3. And 2 times 3, that's 6, which is what I got on the left-hand side. So that's what this equals sign, that's what this equals sign is saying in the middle here. If I do it this way and I do the multiplication of the things inside first and then take the square root, I'll get the same thing as if I took the square root of each part and then did the multiplication afterwards. The question is, why does this work? Why should this happen? I just wrote tis. Why does this work? Okay. And the answer to this is that actually comes back to some of the work that you did really, really early on in primary school when you were learning your times tables. If you do 2 times 3, or you do 3 times 2, they actually mean the same thing. You can swap the order that two things do multiplication in, and you'll get the same thing. These both give you 6. And this actually relates to this exact result here. Let me show you what I mean. Let's look at the left-hand side here. The square root of A times B. Okay. Now, what we're going to do is we're actually going to square this left-hand side. So if I take the square root of all of A times B and I square it, okay, now this is looking really scary and complicated here, okay. Remember, all this means is A times B, sorry, the square root of A times B times the square root of A times B. So what we mean here is square root of A times B times the square root of A times B. That's what the squaring here means, okay. And if we look at that expression and come up to the top here, Our first surd law said that if I have a square root and then I square it, I just end up with whatever I started with. The only difference is instead of just an a under here, I've got an a times b. So if I take the square root of a times b and square it, I must just end up with a times b. Alright? That sounds pretty obvious. Okay, what's the point of all this? Well, what we can do is we can take the right-hand side of this expression as well. Let's take the square root of a times the square root of b. And I'm going to take this expression as well and square it. Now, the logic of what I'm doing here, I've got two different expressions, okay, and I'm going to square both of them. And if the result that I get out is the same, so if by squaring this thing I end up with a times b as well, then I can kind of conclude that whatever I have here must essentially be the same as what I have here. Okay? So let's take this second expression that I've got. And we've already said that squaring just means multiplying something by itself. So the square root of a times the square root of b all squared is the same as the square root of a times the square root of b times the square root of a times the square root of b. And in fact, these brackets that I've put here, we actually don't need them. All we've got going on here is multiplication, multiplication, multiplication. So I can actually just rewrite this as square root of a times the square root of b times the square root of a times the square root of b. And we can reorder these multiplications. Just like in primary school, okay, where the order of a thing didn't matter, okay, we just said that. 2 times 3 and 3 times 2 both equal 6. Okay, here's a bunch of multiplications. I can change the order. So I'm going to change the order of these. I'm going to put the two A's first, and I'm going to put the two B's second. And I want us to focus on each of these parts separately. Now, square root of a times square root of a, that's just another way of writing the square root of a squared. Just give myself a bit more space here. And square root of b times square root of b, well, that's just another way of going the square root of b squared. And this multiplication still hanging out in the middle there. Once again, from our surd laws, our first surd law, if I take the square root of something and square it, I get whatever that something was I started with. So I've got the square root of a squared, that's just a. The square root of b squared, well, that's just b. And hang on, that is the same as I got up here. So if I take this expression here and square it, I end up with a times b. If I take this expression here and square it, I get a times b. So I can kind of conclude that, well, the results of squaring are the same. So that means that what I've got on the left-hand side, this square root of a times b all squared, must be the same as the square root of a times b times the square root of b all squared. So because these right-hand sides are equal, I can conclude that square root of a times b all squared is the same as this thing, square root of a times square root of b squared. And, well, if both sides squared are the same, well, it probably means that a times b, square root of a times b, is equal to the square root of a times the square root of b. Okay. That was some pretty heavy mathematics. That was what we would call a mathematical proof. Okay. Here we have the law at the top, and we kind of talked a little bit about how it works. And down the bottom, I've actually proven that rule. Okay, I've proven that it's always going to work. Now, this is, I guess, the difference between college mathematics and high school mathematics. In high school, you sort of got this rule thrown at you, and you were expected to just use it. Here we have a proof. This is a mathematical argument about why this statement, this rule is true. So I've actually taken you on a journey through this working to get to the answer and say, well, that's true. And actually, in fact, in maths, we sometimes write a little abbreviation at the end, QED, to say it's Latin, and it basically just means I've finished my proof. If you're interested, you can actually look up exactly what this QED stands for, but that's often how we round the proof out. And it basically says, I've shown what I was meant to be showing, that this was true. Sometimes it's really hard to follow a proof the first time. Maybe you got lost in that demonstration. It'd be a valuable exercise to try and go through that as I explained it and understand what was happening at each step. That can be really good for your mathematical understanding. But you also need to be able to use it to simplify things, which we're going to be doing in the next video. Hopefully that was beneficial, and I'll see you in the next video.